All right. Let's do a quiz solution video now for quiz 7. And quiz 7. First question: which energy diagram below represents a concerted exothermic reaction? Right. Well, concerted means it all happens in one step, right? And exothermic means that the activation energy, the potential energy of the product will be less than the potential energy of the um, reactant, right? And so here we have a single step and a potential energy that's lower than the starting material. So the answer there is C. Next question. Which of the following energy diagrams shows the reaction of with the smallest activation energy? That one's pretty easy, right? These all have pretty normal looking, and this is not even a reaction coordinate diagram. But the one with the smallest one is A. Identify the arrow that has a nucleophilic site. So which part of that molecule can actually act as a nucleophile? The only thing here that has lone pairs capable of acting like a nucleophile is this carbonyl oxygen right here. So the answer there is A. Next, which of the structures below cannot be a nucleophile? Well, bromide has electrons that can be a nucleophile. There's electron density right here that can act as a nucleophile. And there's electron density there that can act as a nucleophile. So all those are all nucleophiles. That means that the answer here, the carbocation, cannot be a nucleophile. In fact, it's an electrophile. Next, identify the appropriate arrow in this equation shown, right? So the point of this question actually is to notice that one of the reactants is water, okay? And even though it can go through and make water, but this is also a reversible reaction as well, because the water is still there to go backwards. So this would be the B, one where you have a forward reaction and a reverse reaction. I don't know which side is more favored in this particular one, right? But we just need to know in this particular question that they're going back and forth. And the reason why I want to say that and point this out is because there might just be a question that's very similar to this one, but instead of the water being able to go back and forth, right, it's going to be something else where the one of the reactants, after it reacts, excuse me, right, after it reacts and makes the product might just float away, right, because it vaporizes or something, or it's a gas, right? And then it will not be a reversible reaction anymore. So pay attention to that. Okay? Next, will this carbocation will this cation undergo rearrangement? No, it will not undergo rearrangement because we have a tertiary carbocation here with no double bonds, so that's the most stable it's ever going to be. Okay? Next, identify the sequence of events for the curved arrows. We have a proton transfer to that carbon, right? And then we have the chlorine acting as a nucleophile, doing a nucleophilic attack on the tertiary carbocation, giving you the chlorinated methyl, right? Or tert-butyl rather, right? So that would be first, proton transfer, next, nucleophilic attack. Which one says that? Here we go, C. Proton transfer nucleophilic attack. All right. Identify the sequence. Identify the curved arrow electron movement in this steps in reaction. That's the same thing as the last question, but it's going to be a different thing happening now. Again, we have a proton transfer to the carbonyl oxygen right there, and then we have a base pulling a proton off, right? Making a double bond there, and then oxygen regains some electrons, making it neutral, and now we have an alcohol and a double bond. So quite literally what's happening here is 2 proton transfers in a row, so that's answer D. Okay, which of the following shows likely correctly uses, which choice shows the likely correctly uses, what? Typos. Uses the uses arrows to show the movement of electrons in their direction shown. Okay, so this is really just picking the one that has the arrows going the right direction, and and making sense. Okay. I have no idea what this is. I don't know what's going on there. Okay, so that's definitely wrong. That's definitely wrong. Okay. This could work right there. That could definitely work right there. But then the water leaves, so that works too. Water leaves as a leaving group, pretty easy. It's a good leaving group, right? But if water leaves as a leaving group, how the heck do we have a carbonyl over here? This oxygen would be gone, so it can't be this one. And then this works again. Proton transfer, making a water leaving group. That's good. Okay, that's good. Where the heck did this extra carbon come from? Where the heck did this extra carbon come from? Right there. That's just, I don't know what the heck's going on there. And then this, well, so technically this can happen, right? That can happen, but nothing else is happening now. You'd have an oxygen with a plus charge here, right, and an H. And, I mean, theoretically, a base could come and pull off that H, but there's no steps in between for this, right? And then there's also a proton there that needs to go away somewhere, right? Another base. So, yeah, this is wrong, too. There's missing a whole bunch of steps. So, the only one that's correct, then, is structure 2. Proton transfer. Okay? And so, this is a proton transfer right here. But then notice that the rest of this is actually an elimination, right? A unimolecular elimination, which is an E1 reaction, right? We have the loss of the leaving group, leaving us with a positive carbocation, right? Base comes over, pulls off a proton, comes down, forms a double bond, right? So that's an elimination reaction. Answer is 2. And then last question, identify the nucleophile and electrophilic sites on the substrate and their agent, right? So obviously over here we have a methoxide, so that's going to be the nucleophile, D. The only one that has D labeled as nucleophile is D. And then let's just make sure electrophile is B. Yes, this would be the electrophile being attacked, right? That's going to be the site of the nucleophilic attack. Okay, and that ends our quiz solutions video for quiz 7. Good luck with everything you have left to do today.